Newton's method. Oh boy. Well, there's an equation that says the next point, xn plus 1. I'll just write it down and show you how to use it. It's xn minus f of xn over the derivative at xn. What does that mean? Here's the question. I want you to solve this equation. F of x equals e to the x plus x. Find the roots or the zeros. What does that mean? I want you to set that equal to 0 and solve it for x. And good luck to all of us. We do not have any way to solve this really for x, unless we use a graphing calculator and says, find that. If the equation was a simple one, like different example here, f of x equals x squared minus 2, and you want to find the roots or the zeros. Roots or zeros, the same thing. You set it equal to 0. You take the minus 2 here. And what's x equal to? Plus or minus what? The square root of 2. That we can solve. This we can't. So we need a way to be able to solve any of these. If you encounter a problem like this, we need a method that will help us solve it. And that's where this one comes in.
Newton developed it or what?
Yep, Isaac Newton. Here's what Isaac said. Start by picking any point you think might be an answer. It doesn't matter. But here's the bad news. If you pick some crazy point, you could be there for hours. So I'm going to actually give you a starting point so we're not here for 6 hours. Let's start with this one first because we know the answer to it, then we'll go to that one. So let me do this one first. I want to find the roots for this. We know the answer is plus or minus the square root of 2, which is roughly 1.4. We're going to need the derivative of that while we're here. What's the derivative? Which is 2x. Isaac said, start by guessing on the answer. Go, I'm not really sure what the answer is. Let me use 1 for a solution. I want to see how many times it's going to take me to go through it. So let me use the solution to be 1. Is that really a solution? How do you know if that's a solution? If you plug it into f of x, does your answer equal to 0? If it is, that's your answer. Well, let's take the 1, plug it in here. What is 1 when you square it? 1 minus 2? Oh, that's not an answer. So, that's not a solution. Let me try a different point. Well, what's the different point? Well, you're not going to guess on the next point. Because if you keep guessing, you will never get it. So how do we find the next point? Newton said, well, the next value is going to be the previous one minus f of x over f prime of x. So I'm going to make a table so we can figure out what the next number is. It's going to be a long one here, probably 5, 6 tries before I get the answer. So I need the derivative now of x. What is the derivative when x is minus 1? What's 2 times a minus 1? Negative 2. And now let's do it in color steps. I'll do, instead of jumping to this in one step, maybe I'll break it down to 2 steps. Let me find f of x over f prime of x. Negative 1 over negative 2, which is what? 1/2 or 0.5. And the next value, it's going to be the previous one minus this one. So it's going to be, the next value is going to be 1 minus the 0.5. What's 1 minus the Yeah, that's the derivative is plus 2, not a minus 2, right? 2 times a 1, which is what? 2, right?
Wait, where did you get xn? What is that? 1.0?
Which one?
The xn.
xn, that's the initial guess. This one. That's x, the next value. Now this would be a minus here, right? When you divide them. So let me just go back. That should be a plus here. 2 times a 1. So I guessed on my point, my root. So let me guess by using a 1. I can guess any number. I guessed I started with a 1. I said, could the 1 be a solution? If I'm lucky, this will be a 0. Nope, it's not 0. So it's not an answer. So I'm trying to find what the next number is. To find what the next number, I need the derivative at 1. The derivative at 1 is 2. Divide the two numbers, that's negative 0.5. So the next number should be, that's what this one is saying, the next number should be this one minus this one. That's what the equation says, xn minus this answer. What's xn? 1 minus a negative 0.5, that will make it what? 1.5. Now let's try the 1.5, see if that's a solution. 1.5 squared is what? 2.25 minus the 2, that's 0.25, right? Close, but it's not yet there. What is the derivative at 1.5? What's 2 times 1.5? Is that a 3? What's 0.25 divided by 3? Is that 0.08333? I'll take a few numbers. So the next value now I'm going to be using is going to be the 1.5 minus the 0.08333, which is what? 1.416667, whatever. Let's see if that number is good. 1.41667. Square it and plug it in. That's 0.00695. Close, but I want to get closer. What's the derivative? 2 times that number. 2.8, right? 2.83333. Divide this by that. Divide this by that. What are we going to have? Is that 0.002425? Guess what the next number is going to be? 1.416 minus that number, which is 1.414216. Let's try that number. 1.414216. Plug it in. What's the answer? One 41426 squared minus the 2, and this is what I got, 0.00013. Is that a good answer? Close enough. I'm happy with it. I mean, I can pinpoint more, but if you're looking for an answer in the neighborhood, that's a good answer. So you found the solution to that equation. What we're doing, actually, just to give you an idea of what we're doing graphically, x squared minus 2, it looks like this, the graph. You said, I'm going to try the 1. The 1, actually, you come down here, and you found a tangent line, which is right there. If you draw a tangent line across the x-axis right there, you go, oh, let's see if that's the solution. No, it's not. The next point is You do the tangent line, then you go across the zero. Now let's go up there, and let's do the tangent line. And that's right here. I gotta enlarge that picture to see it. Like this, to enlarge it. So this is your first one. I'm going to use that. So that becomes your next value. Oh, my next point is going to be this. Right there. The next one is going to be the tangent line. Go up there, and that's your tangent line right here. And that will be move it up, and that's the tangent line. So you're getting closer and closer to that point. That's what's going on graphically. For the other one, EX plus X, we have no idea what the solution to that. This we know the answer without having to do it this way. So let's look at the other one, f of x. What's the derivative of that while we're here? E to the x plus what? 1. The book actually is kind to us for the homework assignment. They tell us what to start with, knowing if you pick a 1 here, it might take about 40 calculations before you get to it. So the book actually will be kind to us. What I do if I was doing this myself, I'll graph it on my calculator and see where it does it cross the x-axis. Look closely. Oh, I see maybe it's like a negative 0.5. Let me pick a number around that one. Start with that and go from there. So the first number I'm going to choose here, let me use negative 0.6. Actually, the book told me to start with that. Is that a good solution? Is that a solution? Let's find what f of x equal to. So take the negative 0.6, plug it into that problem up here. If I plug it in, that's negative 0.05119. Not bad. But I'm looking for a closer answer. What's the derivative at that point? Plug it into this one. That'll be 1.54881. Now I need to calculate the next value. I'll do it in 2 steps. I'll do f of xn over the derivative. And the last one, the next value, n plus 1, that means the next. That's really what the n plus 1, the next number, is the previous one, the n, subtract from it f of x of n over the derivative of x of n. So when I divide these numbers, this by that, that's negative 0.03305. So my next number is going to be negative 0.6 minus a minus, that's a plus. Negative 0.6 plus 0.03, it's negative 0.56695. Let me try that number. So this is calculation number 2. We always keep track of how many calculations, just curiosity. You'll see that sometimes takes about 40, 50 calculations. Now, if I was doing programming, I can write a small program that will do that for me, and it will go 1,000 calculation. And I can tell them I want the error to be 0.000000001. And that will tell me how many calculations it took there. So let's try that number now. Is that a solution? Plug it in now. And we're getting 0.00030. That's good. We're getting closer. The derivative of that, plug that number into this one. 1.56723. Divide this number with that number. 0.00019. Now the next value is going to be what? This one minus that one. That's a negative number minus a positive number. So it's going to be a negative number. and you're going to be adding them. 0.56714. So let's try that number now. You have, I think, 2 or 3 problems for homework. That's it on this section. With negative. Negative, yep. Now let's plug it in. And what do you know? Guess what it gives me? Zeros. Done. Now I guarantee you, if I put a 1 here or a -1, I'll have about 40, 50 calculations. But when you have a problem like this, you have no idea what the solution to it. It really, there's no other way besides just going on the computer, write a program, or go to your calculator or Mathematica and just give me the roots. Before programming, before calculators, that's how they did the calculations. Keep guessing. So actually, if I do graphic, like I'll make the picture look crazy. I don't know what the graph looks, but this will give me a better picture. I might guess this is my first answer. I go, well, I mean this one. Is this a solution? Not really. Notice the y value is too high. So what's my next number? We draw a tangent line to this. We go, oh, that's my next point. Is this a solution? Here's one little problem. If you end up hitting one of these points right here, you are in trouble. Why? Because what's the tangent line now? How do you know you hit one of those points? The derivative will be 0. If the derivative is 0, can you divide by 0? No, so you got to go back and repeat the process out with a different number. Oh, wait a minute, that's not good. So let's just make sure this graph doesn't end that way. We'll say, well, it was like this. So my next number is going to be, there's a tangent line. Oh, I got to use this point. That's this one here. Let me find where that tangent line is. And you keep going that way till you find your answer. That is Newton's way of finding a solution. Again, probably 3 problems on the homework from this. That's it. And as I said, the book actually tells you what to start with, knowing this could take hours to do. So they make sure it doesn't go more than 4 or 5 tries at it.
Are you going to increase the amount of errors we have just for this homework?
This one? No, that's an easy one.
5 errors on the entire chapter, that would be good.
What do you mean 5 errors?
Like 5 chances to get each question.
Oh. How about 1 chance? Right or wrong? Get out of here. No.
Are we done?
Unless you have questions now. That's the end of section 8. If you have questions, stick around. That was the longest. Like a brutal day. It looks like I never stopped breathing.